name is Camila Saavedra Lozano, and I am going to be presenting LAMP, our Urban Infrastructure Disruption Analysis methodology, as part of our capstone project for the Department of Technology Management and Innovation of the NYU Town School of Engineering. To give a little context of this project, we need to look at what the Utilidor task group has been doing since 2006 to explore the idea of implementing a transitable linear subsurface infrastructure. Our work here is the analysis of data to help them make the decisions on how to go on with this project. This project was developed on fall 2021 as part of the NYU Tandon MOT program, and we're going to be presenting the results of a 6-month consulting effort and data analysis that we did in conjunction with the Utilidor group. So what is LAMP? LAMP is a methodology to understand disruption in urban environments. So it is a way to locate urban data, understand how it is connected and how are disruptions happening, and then inform decisions by allowing risk to be pondered and for all the different connections between systems in an urban environment to be collectively synthesized in a way that decision makers can use to prioritize projects. What is the scope of our work? We are going to locate the disruption, understand the systems that are involved in them, and look at the way that we can benefit the most the communities that are surrounding them. We're looking to create a methodology that locates, analyzes, measures the risk and impact of a community, and prioritizes disruptions to infrastructure systems in a human-centered way for collaborative project planning. Why is this important and what is the context of this particular project? We've discovered that right now data is decentralized. So there is no single source of connected information of all different utilities that are going through cities. At the same time, the process for project approval doesn't allow for a lot of collaboration between agencies. So we have different agencies that have their planning for the projects that they want to develop or the projects that they want to execute in a given year. They send it for approval, where all of these projects are reviewed in terms of the project scope and the estimate versus the priority of the office, which is the long-term planning of the city, major priorities, everyday endeavors, and the city council. And then the projects are approved and scheduled. However, if two projects have similar scopes or two projects of different agencies can benefit from each other, they are approved as a joint project. This means that a project that was previously two different projects with two different estimates that were not connected and two different scopes are now joined in a way that it's not always compatible, which results in overcost, delays, and a lot of rework. So what we want to do is create a way to have a process that is strategic, connected, and efficient for the planning of projects that uses the collaboration of different agencies right from the start and allows for the scheduled projects to be properly managed. We also currently have the issue of traceability. There is no single reliable mapping of all the utilities that go through a city, which means that there are different systems that are not properly located and can create risk areas when they clash with systems that they shouldn't be clashing with. Another main element of our concept is collaboration. We want to increase the collaboration of all agencies so they work with a common objective and they can create projects that combine all the different benefits of individual projects into one single effort. Finally, there is a lot of risk by not knowing exactly what is going on with subsurface infrastructure, and there are risk areas that haven't been properly located and that can present danger for the community when they have disruptions. Another element of the context is the current data that is used for this type of project planning. There are transportation permits and records, weather and environmental data, pollution reports, accident reports, community alert systems such as complaints, and population records. This brings us to the LAMP principles, which are the guiding principles of this methodology and the way that we are addressing the need to know more about how disruptions are presented, how disruptions are connected, and how they can be prevented. The first of these principles is the data to wisdom model, and this refers to the way that we currently are gathering urban and community data that is going to be processed and connected to create information about the different disruptions that are happening in the city, and then is given context to understand vulnerability within these disruptions to finally reach wisdom about how to address them. However, this methodology is only about the first 3 steps of this model, since we're presenting the information for decision makers to analyze the information in a synthesized way that allows them to make decisions and look out for the best way to address these disruptions. Another important principle for LAMP is that we are solution agnostic. Even though this project first originated as part of the Utilidor task force, we are not necessarily looking at only Utilidor as the solution for the disruptions. We want to provide the information for decision makers to properly match solutions to disruptions without having to look only for one possible. Another principle is that we are city agnostic. Even though our case study is based in New York City, the methodology, principles, and data analysis that is part of LAMP can be used in any urban setting by having a minimum requirement of data that needs to be gathered for the methodology to work, the optimal that we currently have for the methodology to present all different urban disruptions, and any extra data that can be used to complement the current model and create an advanced study. What are our resources for this methodology? We have city data, which is comprised of the understanding of the current planning process, city and state department data, such as the Department of Transportation or the Department of Parks and Recreation, the information of current planned projects, and information on priorities for the city. We also reviewed published research on what has been done in the past, what is currently being developed in this particular setting, and possible solutions for different disruptions. We also talked with stakeholders involved in the planning, designing, construction, community development, and city council. So what are the objectives of our locate, analyze, measure, and prioritize methodology? Our first objective is mapping all the information and being able to filter the information to clean the data and remove any duplicate or unreliable entries. Then we want to understand how the disruptions are happening and how are they connected. And finally, we want to develop a process that allows it to map it, understand it, and create a way for decision makers to inform planning. The first step of this methodology is locate. Locate refers to a series of gaps that we have presented in terms of data requirements. These gaps or data needed is where are disruptions happening, what is the frequency of these disruptions, what risk do they represent, and what is the impact that the disruptions could have in a particular community. So these different gaps are what is guiding the selection of data. The data here are the different pieces that are going to be filling these gaps. And these pieces are permit data, work records, incident data, environmental risk, community data, among others. These different pieces are then matched to fill in the different gaps. And it is at the same time reviewed so that it meets the conditions that we have for any data set to be compatible with this methodology. And this means that we need to be able to have a compatible storage location for any data set that is going to be introduced into the methodology. The data needs to be in a compatible format. It needs to have a location system or a coordinate system that allows for a proper connection with all of our other data sets, and it needs to be up to date. Then it comes to the analyze aspect of it, and this is where we find common elements, compatibility requirements, units of measure, overlapping, and any additional gaps that we have in our model. Then we go into the measure. This is where we start to connect the data and start to aggregate and unite the different data sets. And we also look for intersections and additional parameters that can be added to create insights with the overlapping of the information. At the same time, we start to create visualization standards referring to the way that layers are managed within any mapping or visualization, the way that visual attributes are going to be generated, and the different symbology that is going to be used in all the visualizations. Then we go into prioritize. And prioritize is about addressing the needs of the decision makers that are going to be planning and creating projects that address the disruptions in the city and the vulnerabilities within the infrastructure of a city. And to do this, we are looking at having spatial and temporal tools that are provided through this methodology for them to be able to make informed decisions. And the way that this is created is by the use of interactive parameters that allow for a time period analysis, specific date, looking at specific date conditions, looking at systems intersections, reviewing and creating parameters to prioritize risk of a particular accident, looking at how weather is impacting all other systems and what are the weather risk of a particular area, and also having a community impact, which means understanding who are the people in a particular risk area and how they're going to be impacted if a disruption happens. So to look how this methodology can be implemented, we created a case study focusing on Manhattan. Why did we pick Manhattan? First, because by being an island, it has location constraints that allows for all the different systems that are going through the city to be properly combined. At the same time, New York City has a lot of data availability thanks to their New York City Open Data program. And the high traffic and high density of Manhattan allows for any kind of disruption and any kind of impact to be addressed and located in a more timely manner. So as we previously reviewed, the first step of this methodology is locate. And locate is understanding that we need to find data that allows us to understand where disruptions are happening, how frequent they are happening, what is the risk of them failing, and what is the impact to the community. And to do this, we have our pieces. And in this case, we use the Department of Transportation street cut permits, reports of street closures, the Department of Environmental Protection flooding maps, 311 noise complaints and sonic data, the census information for population, and 311 vehicle accidents reports. This information was mapped to see how they met all of our identified gaps, and then we review them against the different conditions that we have set for our data standards, which are the sources, reliability, format, location systems, and how up-to-date the information is. This is how the information was also reviewed and how we made sure that it was addressing the gaps that we had and that it met our standards. Then it comes to the analyze, which is when we're starting to aggregate, join, clean the data, and start connecting it. So we have different data sets, and through the use of data analysis tools, we were able to aggregate the information, clean it, filter it, remove duplicates, and have one single data set that was the combination of all our sources and included all the parameters that we needed for our analysis. So this is our clean, aggregate, and join step. Then we're going to measure, which is the creation of parameters. In this case, we were looking at connections to see if we have a permit, how do we know if that permit is a construction permit? How do we know that that construction permit is actually active? Since a permit is only telling me that work is allowed to happen, but it's not telling me that work is actually happening. So in order to find when a disruption has happened and it is actually being addressed, we look at the combination and the connection of the Department of Transportation information on permits with the reports of construction sound complaints and construction street closures, and we find this connection to also understand the different risks that these disruptions are presenting by connecting it with vehicle accident data. And so these intersection points are what allows us to have permits, and sound plus closure gives active work. Active work in a particular area with incidents referring to accidents means that this is a risk area when there is a disruption. And risk areas with the information on population and how the community is represented in a particular area allows us to understand the community impact of these disruptions. And we also created visualization standards to allow for an easy understanding of all this information. Finally, we go into prioritize, and this is the creation of a dashboard that allows for decision making, project planning to address these different infrastructure disruptions. And so we have different choropath maps that show different decision factors and can be customized. Here we are presenting the number of permits and how the frequency of disruptions in any given street. We also have flooding information of Manhattan, and we have vehicle collisions that are caused by construction sites in Manhattan. As we mentioned, all of these factors can be customized, and the decision makers are the ones that define what information they want to see in order to make a decision. So in this prioritized map, we selected vehicle collisions and flooding as decision factors. So we are presenting the number of collisions that any given street is having. We have a risk map that is mapping vehicle collisions and flooding, but it can also present other information that has been defined as a priority for the decision makers. Permits frequency on top 10 streets show areas of interest and also seasonality. Systems involve a number of disruptions allows us to know which systems are the ones that are being impacted the most. And filters allow users to see a range of dates and decision factors conditions and look at a particular date, a particular period, or any other different condition that they want to analyze further. This other decision-making map is looking at how many different companies or how many different permittees are present in every street. So it allows us to see vehicle collisions, the disruption frequency, but also how many different companies are being involved in the disruptions of a particular street. So what are the next steps for this methodology? We want it to be replicable, which means that we want to complement this study with other case studies of other urban areas, and we want to generate interaction standards for decision making that can be used in other urban settings. At the same time, in terms of scalability, and this methodology has the potential to allow for a deeper and longer planning process. This means that machine learning can be developed to find deeper connections of causes and impacts of the disruptions, and the use of predictive statistics and forecasting can allow for not only looking at how data has behaved in the past, but how disruptions can behave in the future. So as a conclusion, currently resources are scattered in terms of understanding subsurface urban infrastructure and how disruptions happening in these systems, and there is a need for collaboration between agencies to properly address these disruptions and the risks that they represent, and finding ways to address them in projects that are not comprised of one single agency, but that are the result of a collaborative effort between different agencies. And it's very important to create interaction points between data and users for them to be able to have a more deeper understanding and for them to be able to shape the way that the data is visualized to highlight the priorities of a particular planning process. And all of these elements are addressed by LAMP, our locate, analyze, measure, and prioritize methodology that allows for the mapping of the disruption, the understanding of how the disruptions are happening, and creates a process for this to be replicable and scalable. We want to thank the NYU Tandon Technology Management and Innovation Department for the opportunity to work on this project, and the mentors for these projects, Mark, Terry, Jabril, and Christopher. Thank you.